We are in section 11.2, and in this section we are going to be talking about some different installment loans. In particular, we're going to be looking at credit card loans and car payment loans. So I think that you'll find this practical, and I think that it'll be easy for you to apply this into your ministry setting. Because these are different types of loans that you will have to find in ministry settings and also in your personal life. The first thing we're going to talk about is APR, which is annual percentage rate. And this is probably something that you have seen before if you have done any type of loan or seen it on commercials. So we're going to look at it by looking at this example. Suppose you borrow $2,000 for 2 years with 10% add-on interest. The amount of interest is, if we look at the interest formula, which is the principal times the rate times the time, would be $400. So you would owe, at the end of that 2 years, you would pay back $2,400. So let's look at what that would look like. So basically, then you are looking at year 1, and then year 2. At the end of that, you would pay the $2,000 plus the $400 in interest. So basically, if you looked at that, you could divide that up, that you would be paying your 10% annual interest rate if you waited to the end of the 2 years to pay it back. So that's how they get the 10% add-on interest rate. So if you waited till the end of the 2 years. Now let's say that you wanted to do it a little differently. Let's say that you wanted to take, and at the end of year 1, you wanted to make kind of a lump sum payment of $1,200. And then at the end of year 2, you wanted to make a lump sum payment of $1,200. So really, you're still paying $2,400, which is the same amount that you owe, right? Because you owe $2,400 altogether with the principal and interest. Now, if you were to do it this way, you would actually end up paying more interest. And so this particular way, the way that the interest would work out, you would actually be paying 13.3% interest. And that's because in this second year, you would be paying a higher interest rate, because the way that it's figured out, you're paying $400 in interest for the entire loan. But this second year, you would have been paying a higher interest rate on a less amount of money. So that's where this annual percentage rate comes from. It basically is figured out on the actual rate that you're paying on the money that you owe at that time. And so it's a big long formula, but so I wanted to kind of just give you just a basic understanding of it. Now we're going to look at a couple of examples of how we actually use that formula. So on the Chapter 11 formulas sheet, I've included these two images right here that are straight from your textbook, and they are installment loan formulas, and it includes this APR formula. And so these are just, this is a formula that you're going to be using a lot in this particular chapter. And so just make sure you've seen a lot of these formulas in the last section, but in particular, one of the things that you want to pay attention to is this capital N is the number of payments. And so it's the number of payments. We usually talk about that in months. And so that's why we say 12 times T. T is always in years. And so the amount of each payment, that's your monthly payment, is we're going to take and divide that out. and then your APR is this formula right here, and the APR is an estimated amount, so that's why you have these squiggly lines right here. And so it's going to be based off of the total number of payments and the rate. So that's all that you need to get the APR. All right, so let's see how we're going to use this formula. So we have this example. Consider the purchase of a computer with a price of $1,399 paid for in installments over 3 years at an add-on rate of 15%. Use the given APR formula, rounded to the nearest 1/10 of a percent to approximate the APR. Okay, now this particular section, you want to pay very close attention to how they want the answer. And I will tell you that every single problem is probably it can be very different. Some of them they're going to want 1/10 of a percent, some of them they'll want 2 decimal places, some of them they want no decimal places. So just know that that is very aggravating, but that's just the way WebAssign does it. So whenever it comes to putting your answer in, just double check how they want the answer put in, and whenever you go to put your answer in final. Okay, so what we're going to do is we're going to look first and get our APR formula. Okay, so in our APR formula, what we need right here is we need the total number of payments and we need the rate. All right, so the total number of payments, if you look into this formula, it says that it's over 3 years, and then the rate is 15%. Now, the number of years is 3, so my N, remember I said that we needed that in months, so we're going to say that N is equal to 12 times 3, which is 36, because we need that capital N to be in months. So I'm going to get that N is 36. My rate is going to be 15%, so it's going to be 0.15. So now I can plug all of that in. So I'm plugging everything into the formula. I have everything I need. 2 times 36 times 0.15 over 36 plus 1. Now I'm going to use my Desmos calculator again, and let me clear this out. And so I'm going to use that again. Hopefully you liked that from the last time. So let's see if we can just go ahead and plug all of this in. I'm going to go ahead and get a fraction in here, and I'm going to have 2 times 36 times 0.15 in my numerator. And then in my denominator, I'm just going to go ahead. I know that 36 plus 1 is 37. And then I'm going to do enter. Now let me look and check again. It says that round to the nearest 1/10 of a percent. Okay, this is percent, so I know that I have to have 2 decimal places for a percent, and then if they want 1/10 of a percent, that's 3 decimal places. So I know I'm going to need at least 3 decimal places. So 0.291, I'll go 4 even, 2918 or 9. So let's just see how many I took this answer out to. So on here, I rounded it to 0.292. So 0.292. And then whenever you move the decimal place, it would be 29.2. Okay, so whenever you do the percentage, it's 29.2. Okay, so again, let me pull up that Desmos calculator again so you can kind of see what we did is we did the 0.292, we rounded that, and we got it from here. And then we moved our decimal place to put it into a percentage. Okay, so everything came we just put it straight in from our calculator. And that is finding APR. All right, let's look at another example. Okay, we're going to look at credit card payments, and this is 3 different ways that credit card companies use to calculate your monthly payment. And so I'm just going to tell you that a couple of these ways, they'll just give you a headache. But credit cards are a headache anyway. So, just sorry ahead of time. All right, so calculate the monthly finance charge for the credit card transaction. Assume that it takes 10 days for a payment to be received and recorded, and that the month is 30 days long. Now, some of your homework problems, this will say 31 days long. So it'll go back and forth between 30 and 31 days. So just know that and be very careful whenever you're working your problems. Round your answers to the nearest cent. So that's 2 decimal places. All right, so here's our problem. $550 balance, 21% interest, and a $60 payment. Okay, so the first way that we are going to talk about is called the previous balance method. So in this particular method, they basically go off of your previous month's balance. Okay, so your previous month's balance in this particular example was $550. So what they're going to do is, this one is actually the easiest of all of them, is they're going to take your simple interest formula and they're going to say that they're going to take your previous balance, which was $550. The finance charge is the same as interest. Okay, so that's what the finance charge is, your interest. So that's why we're using this interest formula. The rate is 21%. Now your time, remember your time in this interest formula is in years. We are talking about 1 month. And so we will do 1/12 because 1 month is 1/12 of a year. Okay, so that's where this came from. So I'm going to grab my Desmos calculator. If I can get it pulled up, clear that out. And then we're going to say 550 times 0.21 times 1/12. Okay, I'm going to double check. 550 times 0.21 times 1/12. Enter, and I get 9.625. Okay, so 9.625, and so that's what I get is 9.625, and that is your interest. So that is your interest, is 9.625. Now it says to round to the nearest cent. So whenever you round that, you just need to take and round that and make it into money. So $9.63. So $9.63 would be your finance charge for that month. So that's how much interest you would pay in your payment, $9.63. Okay, so that's the first way, the previous balance method. That's the easy one. All right, now let's look at the next method. Okay. The second method is called the adjusted balance method. And I'm just going to tell you that these get uglier. So, yeah, just warning you. So the adjusted balance method. So what this says is that basically we're going to take your balance and they're going to, they're actually going to be nice to you. They're going to say, we're going to take off your payment and then we're only going to charge you interest on that balance. So, I mean, they're being nice to you, but mathematically, it requires a little bit more work. So, So, I mean, it's a nice thing that they're doing. So adjusted balance is they're going to take the $550. You made a payment of $60. And so your adjusted balance is now $490. Okay. So that means then we're going to take the same exact formula, I equals PRT. We're going to do exactly what we did just a second ago, and we're going to put it into our formula with the same numbers, except that instead of using the principal of 550, we're going to use 490 because we adjusted the balance for this payment that you made. Okay, so again, they were nice. So 490 times 0.21 times 1/12. Now I'm not going to pull up the calculator, but you can do it just exactly like we did. So if you pull up your Desmos calculator, plug that in, you would get 8.575. And when you round that, you would get 8.58. Okay. So hopefully you take my word for that, 8.58. So again, it makes a difference. You can imagine if this was a huge balance, it would make a big difference. So, all right, so that's the adjusted balance method. A little bit of work here at the front. Okay, one more method. Okay, now for this last method, you're just going to need to take a deep breath and use your coping mechanisms to help you. This one is not fun at all. This one is called the average daily balance method. Okay, so what they do is they take into consideration that you had a balance of 550 days for the first 10 days of the month, while your check was en route in the mail, because they assume that it takes 10 days for a payment to be received and recorded. This was back when everybody paid their bills by check and sent it through snail mail. Although it still takes 10 days for payments to process these days. I don't know why, but anyway, we won't go there. And then you have $490 for 20 days. Okay, now you can find all of this information on the back of your credit card statements if you want to read all of that teeny tiny little print, and it will tell you which method they use. So it is very interesting. So that's what they're doing. And then what they do is they want to find the average daily balance. Now, if you remember back to your math, when you find the average, like you add it all up and divide by the total number of days, that's what we're going to do. So again, this is not pretty, but that's what they want to do. They want to find out what was your average daily balance for the entire month. If you carried a balance of 550 for 10 days and 490 for 20 days. So here's what that looks like. So if you're going to find that average, you would say 550 times 10 plus 490 times 20. We're dividing that by 30, which was the total number of days. If you have a month that's 31, you would divide this by 31. When you do that, you get that the average daily balance was $510. Okay, so that was your average daily balance. Now, that's going to be important. We're going to use that in a few minutes. So then we go back to our formula, I equals PRT. Now, this one also uses a little bit different. We know that our rate is 0.21. But our time is different here too. Our time, because we're looking at a daily balance, our time is going to be 30 days out of 365. So again, I know this is so confusing because sometimes we use 360 and sometimes we use 365. Well, this uses 365 because we are talking about just these credit cards use 365. You just need to make a note. Credit cards use 365. This is why I let you use notes on tests, because no normal person needs to memorize this stuff. So write it down. Credit cards use 365. Okay. So, all right. So this is 30 out of 365. Again, if you had a problem that said 31, and you were using 31 days, this would be 31 out of 365. Okay. All right. So then you would plug all of this. So let's just plug that in because that looks like a fun problem to plug into Desmos. I like to plug fun problems into Desmos if you haven't figured that out. So 510 times 0.21 times, get my fraction. The uglier, the better for me in Desmos. Like, I like ugly problems in Desmos. This one's not too ugly. Okay. It is 8.81. 8.81. Okay. So that's your interest, $8.81. All right. So you, well, $8.81 or $8.80. Did I read it wrong? Oh, yeah, I did read it wrong. $8.80. Sorry, $8.80. I didn't mean to round up. 880. Okay, 880. All right, so that's your average daily balance. That's the finance charge and interest on that. Okay, so that's credit card 3 ways. I know that was painful, and I'm sorry. Here we have a car example where you're asked to make a 7% offer on a Toyota Corolla that has a sticker price of $15,143 and a dealer cost of $13,107.75. Can you tell that this book is definitely not written any time like in the last few years? Like no time in the last few years. Definitely not. Because I would, like, if I could go to and get a car for that cheap, I would just fall out. But anyway, so, okay, this problem turns out to be not so bad. So what they want you to do, they give you all this information, but you're not going to necessarily use all the information. To make a 7% offer means that you are going to take the dealer's price and you are going to add 7% to it. And that's the offer that you're going to make. Okay. So what we're going to do is we are going to take $13,107.75 and we're going to multiply it by 0.07. When we do that, we get $917.54. So that's how much we are going to add to that number. So when we do that, we get this number 14,025.29. Now, they say to round your answer to the nearest dollar because, I mean, you wouldn't say, so I'm going to offer you $14,025.29. I mean, yeah, nobody's going to do that. More than likely, you would say, I'm going to offer you $14,000. But in WebAssign, you would say, I'm going to offer you $14,025. And that would be the correct answer. Okay. So they wanted you to round it to the nearest dollar. All right. I hope that makes sense. And that one turned out to be not such a bad problem. So I like those problems. Okay, we're going to look at one more, a couple more car example problems. This one is assume that a car can be purchased for 0% down for 60 months in lieu of a rebate. And a car has a sticker price of $38,290 with factory and dealer rebates of $5,000. So they're going to give you a couple of different options on how you can purchase this car. So the first option is that you find the monthly payment if you finance the car for 60 months at 0% APR. And they want you to round your answer to the nearest cent. So if you finance this at for 60 months at 0%, what you're looking at right here is that you would assume that the car can be purchased for 0% for 60 months in lieu of the rebate. So basically, you're not going to get a rebate. You're just going to get 0% down for 60 months. So basically, you're just going to take this price right here, and you're going to finance this price for 60 months. So whenever we do that, we have option 1. To get your monthly payment, you're going to take your total amount and you're going to divide it by the number of payments. So it's actually pretty easy. We're just going to take that $38,290 and we're going to divide it by 60. So when we do that, we get $638.17. So that would be your monthly payment. So just the total amount divided by the total number of payments, $638.17. All right, so that's your first option. Now your second option is, what if you decided to finance it and you decided to do the factory and dealer rebates? So it says find the monthly payment if you financed at 2.5% add-on for 60 months. This says a car has a sticker price of $38,290 with factory and dealer rebates of $5,000. So if you finance this at 2.5% add-on for 60 months, that basically assumes that you're going to take the rebates. So what you have to do then is you have to find out what is the total amount that you're going to finance. Well, first of all, you have to look at what is your principal. Well, because you took the rebate, your principal is going to be less. So your principal is going to be $5,000 less because you took the rebate of $5,000 less. So we're going to subtract this $5,000. So now I have only $33,290, and that's how much I'm going to finance. Okay, so then my rate is 0.025, which is the 2.5%. My time is 60 months divided by 12. Because remember, I have to have it in years. Okay, so 60 divided by 12. And so now I'm ready to plug all of that into my formula. So when I plug all of that into my formula, I can plug all of this into my formula, plug it into the calculator. And when I do that, I can plug that in and pull out my Desmos calculator, plug all of this in, and when I do, I'm going to get that the total amount to be repaid is $37,451.25. Okay, that's the total amount that needs to be repaid if I take that rebate. All right. Now, I still haven't answered the question because the question was find the monthly payment. So this is the total amount to be repaid. So now I have to do just like I did over here. I have to take this total amount and I need to divide it by 60. All right, so I'm going to do that. So I'm going to take the monthly payment, 30, or the total amount, and divide by 60. So I took this payment, this amount right here, divide it by 60, and I got $624.19. So when you look at these two options, which option is better? So you have to kind of look at it as to which option would be better if you were going to be paying by monthly payments. Well, if you need a lower monthly payment, then taking the rebate would be the better option because you would end up with a lower monthly payment. So because this option gives you $624.19, this option gives you $638.17. So option 2 is going to give you the better option. It's not always the case. Sometimes the 0% will give you a better option. But you have several different questions like this on your homework, and they're going to want you to kind of compare the two options and see which one is better. We're going to look at another car loan example. A car dealer will sell you a used car for $7,452 with $698 down and payments of $159.73 per month for 48 months. And they want you to give the following information. So these two parts are part A, amount to be paid, and the amount of interest. And then we have a couple more parts on some additional slides. So the amount to be paid. So let's take a look at this. In the amount to be paid, first of all, you've got to consider that you're making this down payment. So that's part of the amount that you're paying. And then you're also making payments of $159.73 for 48 months. So that's all part of the amount that you're paying. So the amount that you are paying is you paid this down payment, and then you also pay $159.73 for 48 months. So when you calculate all of this, you put it into your calculator and calculate all of that together, you get that you paid a total of $8,365.04. Okay, so $698 plus $159.73 times 48, the total amount that you paid is $8,365.04. Okay, that's the total amount that you're paying for this used car. Now they want to know in part B, what is the amount of the interest? So basically you have that the amount of the interest is the original price. So you have this original price, $7,452, plus your finance charge, and whatever that finance charge is your interest. And then that equals $8,365.04. That's the total amount. So to find out what that interest or finance charge is, all you have to do is take this amount, $8,365.04, subtract out the original amount, and that should give you the interest. So let's do that. So $8,365.04, subtract out the original amount, and that should give you the amount of your interest. Okay, so that will give you $913.04, which that is the amount of your interest, or what some people call the finance charge. Okay, so that turns out to be not so bad. So hopefully you're okay with that. All right. Y'all okay with this? Yes? I think you're okay. If you're not okay, pause the video and replay it. Okay? Okay. I think you're okay. If you're not okay, pause it and replay. Okay, good. We're going to move on. Okay, now they want us to find the interest rate, and they want us to round that interest rate to 2 decimal places. So what do we know about the interest rate? And so we know interest rate formula, and so the interest rate formula is I equals PRT. What part of this formula is the rate? It's this R. And so what we want to do is we want to solve this formula for R. In order to solve this formula for R, I need to move the P and the T to the other side. So I'm going to divide both sides by P and T. So how that looks is we are going to divide both sides by PT. When I divide both sides by PT, the P's will cancel, the T's will cancel, and they move over here to the other side. So this is a little bit of a reminder from algebra. And so this is what your formula looks like. R is equal to I over PT. Now let's see what all of these different parts look like. So I know that my I, we just found that in the last slide. We found that the interest was $913.04. Now, your principal, they're going to want to only consider the principal after your down payment is taken out. So the principal is $7,452 minus the $698. And so we take your down payment out, and that's $6,754. Okay, so $6,754 is after your down payment is taken out. So that's the only part that they want you to figure this out on. Then your time, again, is in years. And so we want to take the 48 months, divide it by 12, and you have 4 years. So now I have all of my numbers, and let's put it into the formula and see what it looks like. So my rate is equal to I over PT. So that's what this looks like. We're going to plug this in, 913.04, 67.54 times 4. Let me grab my Desmos calculator. And so I'm going to say, let me get a fraction, 913.04, and oops, I didn't want to make it that big. We don't need to make it that big. Okay, 913.04 divided by 6754 times 4. Enter. Okay, so it's 0.0338. So 0.0338. All right. And then what they wanted is they want the interest rate rounded to 2 decimal places. So 3.38%. Okay, 3.38% is going to be my interest rate. All right, so that is my interest rate. All right, hopefully if you need to stop and replay this, feel free to do so, okay? Feel free to do that. The last part of this example is that they want you to find the APR. And they want you to round to the nearest 1/10 of a percent. So again, everything is different, how they want you to round. So just be really careful. So go ahead and grab your APR formula, which is 2NR over N plus 1. And so we're going to plug everything in. So there were 48 payments, and then we just found the rate in part C, 0.0338, and then 48 plus 1 is in my denominator. Let's just, for the fun of it, go ahead and grab my Desmos calculator. In the numerator, I'm going to have 2 times 48 times 0.0338. In my denominator, I'm going to have 49. Okay. And then, so you have 0.0662. So then you want to round that to the nearest tenth of a percent. So again, you want to say 6.6% is the APR. Okay, so that is going to be 6.6%. Okay, you have several of these problems as well where you have to find all of the different parts. Now, the problem with these is that each part is dependent on a previous part. So if you make a mistake on one of the parts above it, then all the parts below it are going to be wrong. So just make sure that you get it, you have to make sure that you get the parts like A right before you go to B, before you go to C. So that's the important part of this particular example. Okay, this is our last example that we are looking at, and I've labeled this the last ugly homework problem because it is the last ugly homework problem that you have. And it is a really long problem, and this is one of those problems that WebAssign likes to put on there and put a whole bunch of stuff on there to totally intimidate you. And so I'm just going to try to take the intimidation part out for you. So really what you need to focus on is this interest rebate formula. All that other part on there is just a whole bunch of extra fluff. So just skip down to where it says the interest rebate formula. So I'm actually going to work part C with you. And hopefully this will kind of take kind of the sting out of it. So part C says $10,100 borrowed at 11% on a 4-year loan with 36 months remaining. Now they gave you this interest rebate formula, which looks really ugly, but I'm going to show you it's not so terrible. They tell you what K is, they tell you what N is. All right, so let's actually work through this problem. And the big thing is to remember that finance charge just means interest. We know what the interest formula is. Okay, so we can find interest by now. You should be very well versed in how to find interest. So interest is equal to PRT. No problem. Everybody say, I'm not scared to find interest, Miss Baker. No problem. This does not scare me. So this is old news by now. All right. So we can do this. So let's find the interest for this problem. Just plug the numbers in. So 10,100 times 11% times 4. This is easy. Okay. So interest is equal to 4444. That's a breeze. That is the finance charge. Okay. So that is what this part of the interest rebate formula is right here. All right. So that's great. Now K in this part right here, it says K is the number of payments remaining. So in part C, it says 36 months remaining. So K is equal to 36. All right. Now, what is N? N is the total number of payments. The total number of payments on a 4-year loan. The 4-year loan, that would make N equal to 48 because 4 years times 12, because there's 12 months in a year, would be 48. Now, that is everything I need to solve this problem. I have K I have N, and I have the finance charge because I just figured it out. That's what I is. So I'm going to come over here and I'm going to say the interest rebate is equal to this ugly formula times I, which is the finance charge, which is the same as interest. I'm going to plug my numbers in. Okay? Grab your calculator. Thank goodness for Desmo's calculator. Okay, so let's grab that. We're going to do our handy dandy fraction. 36 times 37 in the numerator. My denominator is 48 times 49. I'm going to arrow over to the right, and I'm going to say times 4444. And then I'm going to say enter. 2516.76. 2516.76. And that is your interest rebate. 2516.76. And guess what? You're done. And that was all there is to it. And that really wasn't that intimidating, was it? They made this to look like a really ugly problem, and it wasn't that bad. Okay. That, my friends, is 11.2. I know it was a lot. I know it was long, but you can do it. And that is all of Chapter 11 that we're going to do. We're not going to do any more. Thank you, Miss Baker. So, work hard and keep up the good work. You are almost through with contemporary math, and you can put this behind you. Yay! You have persevered. All right. Thanks so much. If you have questions, let me know.